Warm up, okay? Let's see if we remember what the difference is between an open and a closed circle, because that's important, right? Okay. The first thing, we see that we have the ugly notation going on both of these, right? We're just going to start with number 1. How would I rewrite number 1 to be better?
F of G of -4.
Okay. So I'm going to write F first, right? And then what's going to be
And then
parentheses?
G of -4.
Good. And we like this notation better because it makes a little more sense when I look at it as to what's going on, right? We work from the inside out, okay? So starting with the inside there, G of -4, how do I do that?
You plug -4 into your G equation for F.
Yeah, okay? Plugging -4 into the G equation. Everywhere where I see the letter X, which in this case is just one place. Is that how you set it up? We always plug it in parentheses where the X is, okay? When I go to simplify that, what does that become? 13, yeah. 5 plus 8 gives me 13. Okay, any questions there? So now I know what G of -4 is, right? You just told me that it's 13, so now what?
Plug that into F of X.
Yeah, plug it into F equation. F of 13. How do we do that?
13 squared minus 3,
Like that? Okay, perfect. And then I go simplify that. I could do it maybe without a calculator, but if I use the calculator, it'd be a little easier. What's the answer on that one? 130. We all get 130? We agree with 130. Are we okay with this? No? Do you have a question? No. Okay, you're kidding. All right. It's not the nicest looking math problem in the world, right? But we get it. We can do it. That's the goal. Okay. All right. Number 2 looks very similar to that, but is it? No. Okay. What does closed dot mean? Multiplication. Yeah. That's one of my 4 operations, right? We got addition, subtraction, multiplication, division. And those are a different process, right? That means we need to break them apart. Okay, so how would I write the better notation for this?
F of X times G of X.
Yeah, F of X times G of X. Breaking them apart, right? Everybody do that? That's step 1. You get a point for that, okay? The rest of the points then obviously come from evaluating this, okay? How do I set this up?
Like parentheses.
Yeah, I need parentheses, right? Because if I set it up like this, why is this wrong?
The times when goes to 5.
Yeah, that's only timesing the middle 2 terms, okay? I am multiplying the whole F by the whole G. So that's why we need those parentheses, okay? And I already heard someone shout out what this process is. It starts with an F, foiling, okay? Make sure we understand how to do that because that's going to be something we have to do all year. But starting with the first terms multiplied, what's that going to give me? 5x squared. And then, yeah, minus 2x cubed. Minus 15x. Plus 6x squared. I love it. Good. Am I done? Dang it. Combine like terms and put them in descending order. Good. Okay, so what term comes first? Yeah, does he have any buddies? No. Okay, that's okay. What comes after that?
5x squared plus 6x squared.
What are those going to be? 11x squared. And then this guy also doesn't have any buddies. Is that how I do it? Yep, we all agree. How many of you got that before I did? Some of us? Okay. Let's make sure we are asking questions if we don't get it. Let's make sure we're doing our homework. That will be on the quiz. Okay? Both of those things will be on the quiz. So make sure we're clear on how to do composite functions. Okay. Cool. Alrighty, real quick. This looks way more complicated than it is, okay? You're probably thinking, why does this crazy lady keep throwing more letters into math? Just trying to make it more confusing. That's not what this is, okay? This is very straightforward. Again, it's just an ugly notation that they're giving you. They're trying to trick you, okay? So if I look here, m of x equals 2 times f of x plus 3. That's how I would read that, okay? We don't know what m of x is, but do we know what f of x is? What is it? 3x minus 2. It's given to you, okay? So what I can do here is leave everything that's in that equation the same, but plug in what f of x is, because I know what it is. So leaving that 2 in the front, leaving that plus 3 in the back. Then can I evaluate this?
Mm-hmm.
Yes. Okay, what would I do? Distribute. What's that give me? 6x minus 4. And I still have this plus 3. Can I do anything else? Combine like terms. Those two things, right? So you're telling me that m of x equals 6x minus 1, okay? Would you agree with me that that is a y equals mx plus b problem, right? That's all it's asking me to do, okay? I've got it. I got to throw it on the graph, okay? So just like that annoying song I just showed you, okay? We got to know how to do this. Don't mess this up. You learned this in 7th grade probably, okay? Some of you 8th grade, but most of you 7th grade, okay? Don't mess this part up, okay? So looking at this, what's the b value? -1, that goes on my y-axis, okay? And then what is my slope here? 6 over 1, right? Okay, so rise over run, okay? So I'm rising up 6, I'm running to the right 1, okay? I can also stay on that same line but reverse both of those directions, right? To make another point, I could drop down 6 and go left 1 because that's still the same slope, right? Remember this? Okay, really I only need 2 points to graph a line, a straight line like this. Yeah, that's it. That's all it's asking you for. Okay, that's the answer. What questions do you have? Try the next one. Work together. How do I set this up?
Y equals -1
Good. Okay, -1 in the front or just a negative sign. That g is -x minus 4. And then the -6. Do we all do that? Are we all okay with that? So now what happens? Distribute the... That's important, right? I've got to make sure everything gets that negative. What does that do? Yeah, it turns this to x plus 4 because 2 negatives make a positive, right? And then my final y equals is going to be what? X minus 2. And how do I graph that? What's the intercept? -2 first on the... It's always the y-axis, okay? And then what would the slope be if it's just a plain old x? 1 over 1, okay? So up 1 over 1, or down 1, left 1, right? Beautiful. Do we get this? Yeah, should this maybe be a pretty easy question on the quiz because it's on there? And maybe also a really easy question on the test?
How many questions are on?
It's not very many. I think it's 4. Okay. If I gave you something like, you don't have to write this down, but just like, let's pretend I asked you to graph like y equals f of x plus g of x. Technically for this one, if you look at what f of x and g of x are, you could do that, right? Because I could just add up all those like terms and then graph it. We would understand how to do that. Yeah? Okay. Any questions on this before we move on? Okay, there's really only one last big thing left, and that's going to be dealing with these, what we call inverse functions, okay? What inverse functions are? They are the reverse of an original function, okay? So just like inverse operations when I'm solving, right, it reverses that operation. So like if I'm subtracting, I can add something over to the other side, right, okay? If If I'm multiplying, I can divide. All of those are what we call inverse operations, right? Inverse functions are, again, just like that because they're the opposite, okay? You talked about inverse functions when you took Algebra 1, but a lot of times they gave you, for instance, just like coordinate points, okay? So if I gave you like the points 1, 3, 2, 4, and 3, 5, I'm just making these up, okay? If I gave you those points and asked you for the inverse, what do you think you'd do? Just flip them. So it'd be 3, 1, 4, 2, 5, 3. Those are inverse functions because the points are reversed, right? Does that make sense? Okay, real quick, I'm going to show you something on Desmos. How do we do this algebraically? Okay, we know what they look like on a graph now. How do I do it algebraically? It's this 4-step process right here. And the more we practice it, the more it's going to make sense. It's actually pretty easy, okay? The first thing we want to do, we want to rewrite f of x as y. And we already know that those are the same thing. So that's nothing new, okay? The second step is going to be the most important step. That's where we actually take the inverse. We switch x and y. We don't change anything else, okay? We just switch their position. Then after that, we're solving for the new y, and we're replacing it with the new notation, okay? Like I told you last class, Algebra 2 loves ugly notations, okay? This is my ugly notation for inverses, okay? It literally is just f of x, but in between the f and the x, there's this little, looks like an exponent of -1. Why is that our notation? I have no idea, okay? But that is how we notate the inverse, okay? So, moving right along. We're going to go practice this. We're going to do the first one together. Okay, so first step. F of x gets changed to y equals. Whoops. Okay. So far, are you with me? Okay, step 2, the most important step, okay? The step that if I forget to do this, I'm going to get it wrong, okay? That is the actual inverse step. So I'm taking x and y, I'm just changing their position, but I'm not changing anything else, okay? So this y becomes x, the -1/2 stays right here, the x becomes y, I still have +6 at the end. Okay? Now I'm solving for the new y. Okay, I'm trying to get y by itself. So just like I would if I was solving a 2-step equation, right? I need to move over whatever's being added or subtracted first. Okay, so for this one, I'm going to subtract 6. Inverse operations. Oops. Okay, again, trying to get y by itself. So now I need to get rid of that -1/2 that's in front of the y. What are my 2 options on how I can do that? Could divide by -1/2, right? Or I could multiply by the -2/1, right? What do we call that in math? When I take a fraction, I flip it. Reciprocal, okay? So either way, I don't care which way you do it because it's essentially the same exact thing. If it were me, I'd probably just multiply by -2 because -2/1 is -2, right? Okay? So that's what I'm going to do. And if I do that on the right side, I've got to do it on the left, okay? So on this side, I end up with y equals. That's what I wanted. And then on the other side, I'm just distributing -2. Okay? And I'm just about done, but I can't leave it as y equals, okay? Because I just found the inverse, right? It's not actually y, it's the inverse. So I'm just going to change that y to my inverse notation, and that's what equals -2x plus 12. And that's my answer. You could leave it on the right side if you want to, but it's proper to put it on the left. I would probably not take points off for that, though. Does this make sense? Did I lose you anywhere? Okay, so using the steps on the previous page and this example, I want you and your group to try B. Try B. Step 1. What we got? Okay. Step 2. Swap x and y. Don't forget this step, right? It's the most important. That's how we know we're actually taking the inverse. We're switching the location of x and y. Okay, now what? Minus the 1. Oops. Okay, how many of us at least made it this far? Cool. If we didn't, what questions do we have so far? Are we all okay with this? We understand what we missed if we didn't get it. Okay. From here now, what do I do? Divide by -3, okay? So this can be written 2 different ways, okay? It could be written like this. And that's okay, okay? Technically, we don't like to leave negatives in the bottom of a fraction, right? We typically see them on top, okay? The other way that we could write this is we could make this fractions, make them 2 separate fractions because they both have a denominator. The x and the -1 are both over a single denominator, -3, right? Okay. So this would be the same thing as, what'd you say? -1/3 x, and then -1 over -3 would be +1/3. Okay. And this is the way that you're typically going to see it drawn, okay, or written, sorry. And that is because if we go to graph this, this is how I'd want to see it, right? Okay, because if I'm graphing a y equals mx plus b line, it's hard to do it when it's written like this. Okay, can we all see that these are the same thing? Okay. Also, we typically don't leave a negative in the bottom, so technically if I took this negative out of the bottom, I could also write it as the negative being on top of the fraction, right? Which would also simplify to just be -x plus 1/3. Are you with me? Okay. So lots of different ways that one could be written, but again, this is probably the winner. And the last step, I don't really want to leave that as y. I want to change it back to this guy, right? Actually, this was a g, wasn't it? Not f. So this is probably the way you'll want to write it, especially if it's one that asks you to graph it afterwards, like the next one does. But I would still take either of these answers as well. Just make sure we put the inverse notation back on it.
Why do you add the extra, 1/3?
Because what this simplified to, this was x over -3 and then -1 over -3. And if I divide -1 over -3, those become positive because they're both negative. So this fraction stayed negative, right? And then this fraction became positive. Okay? Does that make sense?
Yeah.
Okay, good question. What else? What other questions do we have? Okay. Once again, turn back with your group. I want you to find the inverse algebraically here, and then I'd like you to throw both of those on this graph, okay? So f of x and then f inverse of x. I want both of them to be graphed. And we'll see if they have that same relationship as the one we looked at on Desmos. Okay? Ready, set, go. I told you today would be short. Okay. Starting with finding the inverse with algebra, right? Okay. Help me out. What are we doing? Step 1. Yep. And then switch the x and y. And then add the 3. And then multiply by 2 because that's a reciprocal of 1/2. You also could have divided by 1/2. Whatever works better for you. This gives me y equals 2x plus 6 because I distribute. And then I'm going to rewrite it with my new notation, right? And I'm done with that part. How do we do there? Good? Okay, let's go graph these. Let's start with f of x. How am I going to graph that? Before that. Yeah, -3. And then up 1/2. Or down 1, left 2, right? It's the same thing. Okay. Now what? Now I do the same thing for the inverse. Up 6. Up 2 over 1. Oh no, that's going to go off my graph. Should I start crying? No. Yeah, I just go down 2, left 1. I just reverse it. You could go ahead and put a point off the graph too if that just makes you feel better. That's fine. Okay. I didn't tell you to do this. You don't have to do this, but I'm going to label these graphs just so I can see which one's which. And then my last question for you is graphically, are these inverses? Are they symmetrical through this line right here? Yeah? Would you agree? Okay. What questions do you have? How did we do? We did good? So like, I don't know if this was on a test or a quiz, you'd be all right with it? Yeah. Okay. Or if this was? Okay. All right. Can we do one more thing? It's still the same thing. It's just proving. Okay. I know that what you're thinking, I just said the word proving and your mind went back to proofs and geometry and you're like, oh no, okay? This is not like that really, okay? This is just me verifying if two things are inverses, okay? So if I gave you two functions and I asked you if they're inverses, there's actually an easier way than just going through that whole process twice to figure out if they're functions. And how that is I can plug each one of them into the other. And if they both become x, they just simplify to x, okay? So meaning they cancel out everything else about each other, then yes, they are inverses. If they don't simplify to just the letter x, then they're not inverses, okay? So let me show you how this looks with two examples and we'll be done today, okay? So what this means is they're giving me f and g and they're asking, are f and g inverses, okay? So what this means for me is I need to find f of g of x. I need to find g of f of x. And again, if those end up being just the letter x, this is a yes. If it becomes anything else, it's a no. And yes, you do need to prove it both ways, okay? Because we've got to be able to show that work, okay? So starting with this first one, give me 1 second. Okay, so the first thing, f of g, do I know what g is? What is it? Yeah, so could I plug that into f? I think I could. F of x is just negative 3/2. I could plug this into x, right? So plugging in that whole g and then leaving everything else about f the same. And then simplifying it. Are you with me right now? Do you see what I did there? Okay, so we distribute here. What is negative 3 over 2 times negative 2 over 3x? Those fractions are reciprocals, aren't they? So wouldn't they just be a 1? Okay. What's negative 3 over 2 times 4? It'd be negative 12 over 2, right? Which simplifies to negative 6. And then we add that 6. And if I simplify this, I'm left with x, which is what I wanted. Now to go prove it the other direction. Okay, so we've got g of f. I know f of x is negative 3/2 x plus 6. So now I'm plugging that into g right here. Okay, so when I set that up, I've got negative 2/3 times my f of x, because again, that's what I'm plugging in here. And leave everything else about g the same. And same exact thing here. I'm simplifying. This simplifies to a 1x. This simplifies to negative 12 over 3, which is just negative 4. Those 4s are going to cancel out. I'm left with x, which again is what I wanted. So yes, 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 these are inverses of each other. They're inverse functions. We do have a quiz next class, so make sure we are prepared.